Dear world, welcome back to the series of strings algorithm. So we have already studied a lot of algorithm of this string series, and today we'll be studying the Rabin-Karp algorithm. So what this Rabin-Karp algorithm is? This is basically a pattern matching algorithm. That is, through a string we actually match with the pattern, that how many times the pattern occurs. I mean, first why the pattern first time inserts the matching. So that type of things. So we will understand this Rabin-Karp algorithm in details one by one. So let's start observing what we will understand in this today's index. So first, overview of Rabin-Karp algorithm. First, we will be observing the concepts, that what is the Rabin-Karp algorithm, what do we understand from Rabin-Karp algorithm. Those types of concepts we will be understanding from Rabin-Karp algorithm. Second, key concepts of Rabin-Karp algorithm. In key concept section, we will be describing the main fundamental, that how we can compose the program of the Rabin-Karp algorithm, because it's a little bit complicated. We'll be observing that key concept. First, the major factors in key concept are hashing. So we will be observing this hashing, the sliding window techniques, and prime modulus. These are the three main major key concepts in Rabin-Karp algorithm. First, that is hashing. That means whenever you heard of Rabin-Karp algorithm, hashing comes into a role. Second is sliding window. We use here the sliding window techniques. And third is we apply the prime modulus also. Third, program of pattern searching using Rabin-Karp algorithm. Third, we will be observing the program. Then we will be discussing about the time complexity of Rabin-Karp algorithm. Then we will be discussing about the time complexity and the space complexity. So that's about the Rabin-Karp algorithm that we will be studying in today's index. So let's start to understand the Rabin-Karp algorithm. So first we will be trying to understand the Rabin-Karp algorithm. Before we try, the main function of Rabin-Karp algorithm is to find the pattern. So Rabin-Karp algorithm is actually we can apply the general brute force or naive approach. We can apply the general brute force or naive approach. So what happens in this brute force and naive approach is that we try all the possible combinations. That means all the possible combination we try applying in this approach. Let's say the text. Let's write this text here: A B C D E F G H, and let's write the pattern as ABC, the pattern ABC. So let's say the length, we are assuming the length to be told by n, and we are assuming here the length to be told by m. So if we compare, how we compare these two strings, what we try, our main motto is to find substring. Our main motto is to find similar pattern substring, that we are trying to find the number of same pattern. This pattern, we try to find this matching substring. We try to find the matching substring. That is our main goal, to find matching substring. Our main goal is to find the matching substring. That is our main goal. So how we actually compare? Look, this is the text. So if we try to find for the first time, we compare this A and we compare this A. We compare this B, we compare this B, we compare this C, we compare this C. So first time we compare like this. So now notice how many times we compared here. 1, 2, 3. We compared here equals to the length equals to 3. That means we compare for the length, for the number of lengths time we compare, that is m. We compare here m times, and now observe, we compare here up to all the lengths. First we compare for this length. Up to this length A, B, C. For the first time we compare, and the second time when we got the pattern for the first time, that means we are successful here. Now we try to find the second. Pattern. So this time we move our window in this manner. We again move our window in this manner. So we keep moving our window until this section, until we get the last this area, and this area in terms of mathematical term is n minus m plus 1. This is n minus m plus 1. So observe, the time complexity we get from here is the time complexity we get using the brute force method. The time we get, that is time, how many time it's taking from us, that is the number of times in here, n minus m plus 1. Time required is n minus m plus 1 into, we are searching what? We are searching for all the patterns. Again we are comparing 3 times with this one, with this one, with this one, with this one. So for n minus m plus 1 times we are comparing into m times, that means 3 times or m times. So it becomes n cross m minus m square plus m. So in assumption, in approximation, we call it that big of n square. Now look, the time complexity. This is a very huge time complexity. That is a very huge time complexity, and that is the problem why we need Rabin-Karp algorithm. Rabin-Karp algorithm executes this in a very low time, and that is approximately it reduces into big O of m plus n time complexity, and that is why we utilize the Rabin-Karp algorithm. So that is the main method of Rabin-Karp algorithm. Let's move to the next page and let's study the main concept. The Rabin-Karp algorithm is a string matching algorithm that leverages hashing to efficiently find a pattern in a text. Look, the main things here to notice is that leverages hashing. That means in Rabin-Karp algorithm, which solves our problem in only a time complexity of big O of m plus n. It solves in average, or in best case, it solves the problem in only big O of m plus n. Solves the problem that efficiently, so that leverages hashing. So Rabin-Karp algorithm mainly uses the hashing technique. This is to remember that Rabin-Karp algorithm uses hashing to optimize this method, uses hashing. Now it's particularly efficient when searching for multiple patterns in same text. Look, when searching for multiple patterns in same text, suppose we want to find there was again ABC, after that there was again ABC. So we want to find those all patterns. We want to find this pattern ABC, this pattern ABC, and suppose there was also ABC. In exchange of A, B, there was ABC. So we wanted to find those 3 patterns, and for finding all those 3 patterns in one string or on text, we use the Rabin-Karp algorithm. That is told here that when searching for multiple patterns in same text, we use the Rabin-Karp algorithm. The key idea behind Rabin-Karp is to use rolling hash function to quickly calculate the hash of the current window of text and then compare it with the hash of the pattern. Look, the second important things to notice here, the key idea is to use the rolling hash function. Here we use the rolling hash function. So that is one more important things we get, that in Rabin-Karp algorithm we use the rolling hash function. So now just I am introducing you with the terms. Now we will observe in later that how these things are playing role to construct the Rabin-Karp algorithm. So rolling hash techniques is also utilized in Rabin-Karp algorithm. Now there is the reason why Rabin-Karp. Naive approach checks each possible combination. That means it checks all the possible combination, leading to a time complexity of big O of m cross n. As I told you that it takes a time complexity of big O of m into n, which can also be called as big O of m square. Big O of n square or m square, you can call it anything. So that is the things. Now Rabin-Karp pattern matching hashing algorithm reduces this by computing hash values. Now look, by utilizing the hash value concept, Rabin-Karp algorithm reduces this time complexity by utilizing hash values. And in this video we will be studying the most optimized method of Rabin-Karp algorithm. Now multiple pattern matching, we already observed that this is useful for finding multiple patterns 1, 2, 3. So suppose in lead code you got a question where you have to return the number of times a pattern occurs in a text. For that you can use the Rabin-Karp algorithm. So that was the concept of Rabin-Karp algorithm. Now we'll be studying how the Rabin-Karp algorithm actually works. I can tell you, but it's better for reference purpose, that how the Rabin-Karp algorithm actually works. So as I told that we utilize hashing, we utilize sliding window, we utilize prime modulus for all those. Now I'll tell you that how we utilize this. Look, this is our text and this is our pattern, and what is our main goal? Our main goal is to find the occurrence of pattern. Find the occurrence of pattern. Our main goal is to find the occurrence of pattern in text. Pattern in text. That is our main goal. That we want to find this So how the Rabin-Karp algorithm actually compares is, first we try to compare. First Rabin-Karp algorithm in naive approach compares this and this two, they compare. After that it's removed like this, and now they are again matched, they are again matched, they are again matched. After that we again remove them like this ABC, and now look, every time we are keeping matching, every time we are keeping matching, that means there is repetition. Look here, here is the same BC intersection, here is the same BC intersection, so there is the repetition. These already exist and we are again competing those already existing, and again we are competing in naive approach. But in Rabin-Karp algorithm we do not do like this. We entirely change the idea of this. Instead we first do like this. We don't actually compute those intersection types, we only compute the new arriving. What is new arriving? That one. Now observe how actually Rabin-Karp works. First in Rabin-Karp, when we work with Rabin-Karp, first we utilize hashing. We compute a hashing for it. We compute a hashing value for it. Let's say the hashing value is 43. So we computed this hashing value 43. Second, we computed the hashing value for this pattern also. And let's say this is 43. Cause this is same, so their hashing value will also be same. So when they are same, we now the hashing value is matched. Now we check if their hashing value matches or not. Yes, their hashing value is matched. This is also 43 and this is also 43. They are same. Now we do the character by character comparison. Now we will check them by character. We will take the text part like this, A, B, C, and we will take the pattern part A, B, C, and now we will check if they are same by checking if they are same one by one. This is called character by character comparison. Character by character comparison. Character by character comparison. Character by character comparison. So first what we do, we check for hashing. Second step, we perform character by character comparison. Character by character comparison. Second step, we perform character by character comparison. So that is the hashing. Now when this is done, now look, the third important technique is we use here sliding window technique. That is already written in that site that we utilize here sliding window technique. So what is sliding window technique? Now here there is ABC. Now when we bring the ABC from here like this, let's remove this portion. Now so this was ABC, we have done. Now when it comes into here BCD, this section, so we calculate this hash only for this section. That means now when we calculate hash for the second substring, so we calculate the hash of this one BCD. First we have calculated the hash for ABC. After ABC we will be calculating hash for BCD. After BCD we will be calculating hash for CDE. But here we use rolling hash. That means let's come here, and what is our text? That was ABC, A, B, C, D, E, F, G, H, and the text was ABC, A, B, C. So first what we do, we calculate the hash of it, and let's say the hash is 43. Now we calculate the hash of this section, and they are 43. If both the hash values matches, we check if the hash value matches or not. If hash value is matched, then we do second step, we do character by character comparison. By character by character comparison, as I told. Now the main method we are understanding is rolling. Now it will again calculate the hash value of next string, that is BCD. Now look, now when calculating the hash value of this BCD string, we don't calculate the entire hash value. Instead we will just do like this. If ABC was 43, then we will just subtract the letter A from here, so it becomes BC. Now we have subtracted A, so it becomes BC. This portion is the hash of BC. And now what we have added, observe the letter here, we have added the letter D here. We have added the new letter D here, so we added D with it, 43 minus A plus D. So whatever the hash, let's say whatever the calculation, it becomes 50. So now this becomes the new. Now did you notice we didn't calculate it for BC? For BC we didn't calculate it, it remained the same. Just only we subtracted a constant value that was being out, we subtracted it. We subtracted this A and we entered this D. And this is the rolling hash, that we are only subtracting and adding the required portion. Others are as fixed. So this is the utilization of rolling hash technique, sliding window technique, which is also called rolling hash. And now we utilize prime modulus. Look, prime modulus is used to find the hash value. If sometime due to collisions and sometime due to the arithmetic numbers, there can be the same hash value. Let's say ABC. Let's understand this. Now the letter A, B, C, D, E, F, G, H, I. Sometime it might occur that this string is having 43, and by some mistake this string is also having 43. So in terms of programming language, this is called hashing collision. We call this in programming language hashing collision. Hashing collisions. In programming language, that is called hashing collisions. And to reduce this hashing collision, we try to reduce this hashing collision. For reducing this hashing collision, we subtract it by large value. We subtract it by a large value, which is called prime modulus. In our program, we will be using the prime modulus 101. 101. We will be dividing or making modulus by 101 to reduce that hash collision, that we want that they become the maximum possible difference. If that is 43, it can become 44, 45, but it doesn't become 43. We try to reduce the collisions, and this is why we do the character by character comparison. Because of collisions, same pattern can also have 43. Pattern can also have 43. So due to this collisions, we again match character by character comparison. On only after character by character comparison, we get if they're actually occurring or not. So this entire technique helps us to optimize our algorithm. Now let's understand the complexity. Time complexity. Best case, if there are no hash collision. Look, hash collision term is mentioned here, and I am made you understand what is hash collision. So if there are no hash collision, the time complexity is big of n plus m. The time complexity there is no hash collision, that is all hashes of the substrings are different, then the time complexity will be big of n plus 1. Big of n plus 1. If no hash collisions, if there is no hash collisions, if no hash collisions, then big of n plus m. And if in the worst case, if there are a lot of hash collision, then it becomes big of n star m, similar to naive approach. But this is also a very less approximation chance that it will occur, but on average we get this time complexity using the Rabin-Karp algorithm, and that is why we utilize the Rabin-Karp algorithm. So how we will be making the code, I will be understanding through the code, that is main portion. So first what we do, we calculate our initial hash calculation. First we perform our initial hash calculation, because we calculate hash for all the strings. We calculate hash for this string ABC, BCD, CDE, 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 DEF, EFG, FGH, GHI. So we calculate hash for all the substring. All the substring calculate hash A, B, C, B, C, D, C, D, E, D, E, F, dot. We calculate for all the strings. We calculate the initial hash, and also of the pattern, we calculate the hash of the pattern. Whatever the pattern is, if that is A, B, C, we calculate the hash. And then second, sliding the window. Look, sliding the window, as I told, by sliding the window we get this. We have slided the window, and that is why we got it. And the main thing is here, the sliding window is called rolling hash, because look, BC is rolling here, BC, now CD, CD. So this is also called rolling hash. This is the rolling sliding technique. Now matching process. After that, we check the actual characters to verify a potential. We do character by character comparison. So that is, and these are the main method I have written, that after when we'll be writing the code, we'll get complex functions that I will be discussing here. So this is one of the complex functions that I have already written, so we'll be discussing it later. So let's move to the coding section. So welcome back to the VS Code. I've already introduced to the VS Code. So that is the VS Code. The code is written. So now we'll write the entire code by ourselves. So let's quit it, save, and we're coming in the main directory, command dot dot. So now we'll be creating a new directory by using mkdir. Let's say it's Rabin-Karp writing, because this is for YouTube. Okay, now command. Now we will be moving into that directory, and for that we'll be using cd change directory Rabin-Karp Rabin-Karp. So that is the Rabin-Karp. Now we'll be creating a file code optimized Rabin-Karp or Rabin-Karp algorithm, code Rabin-Karp algorithm .java. So we have created the code Rabin-Karp algorithm.java. Now we will be start writing the code, and before we start writing the code, we'll be writing the imports. So first we have to declare the class, and let's start by declaring the class by utilizing the public class Rabin-Karp. So first we can import java.util.star, and then we will declare the file public class Rabin-Karp algorithm, Now we'll be declaring the ASCII character set private static final integer d equals to 256. So this is the value of d is 256 cause of the ASCII character, cause we are considering all the ASCII characters. We are considering all the ASCII characters. Now we will take a large prime number for the modulation purpose and hashing to minimize the collision. So private static final integer prime, let's call it prime, and we will be taking it 101, and this is a prime number for modulation purpose, in the program. To minimize the collision, we utilize this modulation for minimizing the collision. Okay, now we utilize here a hash data. We calculate the pattern hash, we calculate the text hash, we calculate age. So for that we will be declaring that data type also, that data type structure also. So a simple data structure for here hash data, let's call it a simple data structure for hash data. So let's call it private static class hash data. So we'll be declaring our hash variables: integer pattern hash, integer text hash, integer age. Then we will be initializing the constructor hash data, and in hash data we will be passing all the things: integer pattern hash, integer text hash, integer text as integer age, this dot pattern hash equals to pattern hash, this dot text hash, this dot age, that is equals to age. So these are we initialize the constructor. So after initializing the constructor, first we'll implement the search method, because we actually try to search the number of times the strings, the pattern occurs in the strings or the text. So in this substring we try to search. So we will name this function as search. So let's call it private static integer search, private search method for finding the number of substrings or matching pattern. We try to find the pattern in matching substring. So we'll be pass both the text and pattern. Public static integer search string text will be passing the entire text string pattern pattern, and now integer m pattern dot length. We are calculating the length of the pattern. Look, this is very important in this program because we pass this pattern length a lot of times. And integer n equals to text dot length. We also pass it but a few times. Now we will be calculating the initial hash values and hash multiplier. So right now we'll be calculating the hash multiplier. Because this is very optimized algorithm, so we utilize the most optimized function. So now calculating the hash parameters and hash multiplier h has multiplier h. We utilize here also has multiplier h hash data that is equals to initialize. We utilize here a new function for initializing those, and that is initialize hash, and we pass text comma pattern comma this m, the number of patterns, the pattern length. Now we start sliding the pattern over the text because we need to sliding over. So we will be starting sliding the pattern over the text. Start sliding the pattern over the text for integer I equals to 0, I less than equals to n minus m, I plus plus. Now we'll be checking if the hash value matches and confirm with a string comparison. So we'll be checking if the hash values of the substring and the pattern matches. If the hash value of substring and the pattern matches, if that matches, then we will be proceeding to match character by character, and for proceeding to match by character one by one character, we will use one more function to so now we'll be utilizing that function also, and we will be writing that function also for the comparison. Checking if the hash value of the substring and the pattern matches, and if they matches, then we'll be proceeding towards the function to check character by character. If hash data dot pattern hash, equals to hash data dot text hash, and check equal. We'll be checking, and for checking check equal function requires all those attributes: the text, then starting attribute from where it start, then ending attribute up to what length it will keep checking, then pattern, its starting index, and then its ending index, that is m-1, because if it starts from 0, the index will always be less than that. And now we'll be checking the function. If they matches, that means pattern is found at that index, return I. If everything is fine and the check equal is also true, that means pattern is found at that index. Pattern is found at that index. Now recalculating hash for the next window. Recalculating hash for the next window. If I less than n minus m, now if the value of our I is less than the current range, that means we can enter, then we will be recalculating hash for the next window. Hash data dot text hash, that is equals to recalculate hash. Now we'll be passing the text, and then hash data dot text hash. We'll be passing the text hash data dot text hash. Then we'll be passing the index I, the initialization, then I plus m up to that pattern length. We'll be starting from index I, and then we'll be checking up to the extra length of that pattern. Then we'll be passing the hash data dot h. This h is responsible for multiplier, that is hash multiplier, and m. So this is the recalculate hash. We'll recalculate the hash and assign on the new one. And the important thing is this h. H is the hash multiplier, multiplier. Now after the loop ends, if till now we didn't find the pattern, then we'll be returning -1. That means pattern is not found. Pattern is not found. Pattern is not found. Now we'll be initializing all those functions. So first we'll be initializing the function to find the hash value of both pattern and the first text window. So function to find function to initialize hash values for both patterns and the text, private static hash data initialize private static hash data. The return type will be same hash data initialize hash, and then we'll again pass the text string pattern, then integer m the length of the pattern. Then we'll be initializing all those pattern hash takes as all those variables as 0. Integer pattern hash, this is equals to 0. Text hash, that is equals to 0, and h, that will be equals to 1. Calculating h. So this is h is actually hashing multiplier, and we'll be using the function d to the power m minus 1. This function will be utilizing to calculate actually the h, and then we'll be using the modulus by the prime. So it will actually find out the hashing, and this is used for shifting the window. Now let's calculate. For integer I equals to 0, I less than m minus 1, I plus plus. Then we'll be calculating as told, and as using the function h star d percentage prime. The d is nothing but the ASCII range we already declared above. Now we'll be calculating the initial hash values for pattern and text. Now calculating the initial hash values for both pattern and the text. For integer I equals to 0, I less than m, I plus plus. Pattern hash equals to d star pattern hash plus pattern dot character at I percentage prime. Text hash, that is equals to d star text hash plus text dot character at I percentage prime. Now we'll be returning that new hash data. Then return new hash data, pattern hash, text hash, h. Now we will be writing the function to recalculate the hash. We initialize the hash, and now after initializing we need to recalculate the hash also. So now we will be writing the function to recalculate the hash for the next window in the text. So let's start writing this function to recalculate the hash for the next substring in the text, So we declare this as same recalculate hash, private static integer recalculate hash. And now we'll be passing same string text, integer text hash, integer old index. So we pass first string text, we pass the string text Then we pass the integer text hash, whatever the text hash was previously. We also pass the old index and the new index, integer old index, integer new index, and also we pass the hash calculating function integer h and the pattern length integer m. So we all pass all the arguments to calculate the hash. So now we'll be calculating text hash, that is equals to d star text hash minus text dot character at old index star h plus text dot character at new index percentage prime. Now we will be handling the negative hash value. Handling the negative hash value. Handling the negative hash value. If text hash is less than 0, if text hash is less than 0, then we'll be simply adding the prime value with that. Then text hash plus equals to prime. We'll be just adding the prime and we'll be returning that text hash. Return text hash. Now we will write the check equal method to check both the string. Method to check if two strings substrings are actually equal. Method, this is the first time method to check if two substrings are actually equal. Private static boolean check equal. Private static boolean check equal. Private static boolean check equal string text. Now we pass here string text. We pass both the integer start one, integer end one. Start one, integer end one. String pattern integer start 2, comma integer end 2. And now we check while start 1 less than equals to end 1 and start 2 less than equals to end 2. Now we'll be checking if both the characters at starts are if text dot character at start 1 not equals to, अगर वो same नहीं हो, they are not same, pattern dot character at start 2, then we'll be returning false. Return false. If all the characters matches by default, start 1 will be increasing the count start 2, and if all matched, then we'll be returning true, that means they are equal. Now we'll be writing the main method, public static void main string args string text. Let's call this text a b c d e f g h i, a b c d e f g h i, and let's find the pattern string pattern, that is equals to def. And now integer result search text comma pattern. If result not equals to -1, system dot out dot println pattern found at index, pattern found at index. Now result else system dot out dot println pattern not found, pattern not found. Explanation and optimize. So that is an entire code section, and there are quite tough section that you need to understand. So first, calculating the age value was quite tough. So first we'll check the code. Look, first here we have declared the integer variable d and prime. So d is actually this all ASCII character range that we are utilizing in the function, and this is prime. This is used for modulation. That means we use this prime to lower the value. That means whatever the hash value will be, if that is a large number, we lower it into dual digit values. So for that we use the prime number. This private static class hash data, we are storing there the hash values of both. We are storing the pattern hash, text hash, and the integer age, which is actually a hash parameter multiplier that is used to multiply. So this is, now we start utilizing the search method, where we have passed two arguments, string text and string pattern. Here integer m equals to pattern dot length, integer n equals to text dot length, and then from here we have passed the the text pattern and the number of pattern length in the initialize hash function, and through that initialize hash function has returned us all the values in this hash data object. So let's understand what is initialize. This is, here the initialize hash comes string text, string pattern, and then integer pattern hash text as 0. For integer I equals to 0, I less than m, I plus plus h equals to h star d, percentage prime. So that is quite tough. I think this okay, we can discuss about this if you require that. I will make you understand of the code section how they're working. So this is the actual code. If we work, it will calculate the hash from inside, and then we calculate the recalculate hash using this recalculate hash, and the check equal method checks if both actually the strings are equal or not, and then from here we run this main code. So this is how we compose the Rabin-Karp algorithm. We understand that Rabin-Karp algorithm is used to search the pattern, and this is quite tough. So if you want a detailed description about how we can write the code easily, how we can understand the code, please comment below. So I will make another video. So I'm finishing this video here. Before we finish, let's have a recap. So actually I didn't discuss this portion what I was supposed to discuss. So if you recall it, do a comment, then we'll be discussing about those every section, and we can understand everything in details, like those sections, those portions which are actually a little bit complicated also, those recalculate hash, etc. we can discuss. So for that I need to know if you are actually interested or not. So if you are interested, do comment, we will make a video. So let's move to the beginning. This is Rabin-Karp algorithm from where we start. So the basic difference in Rabin-Karp algorithm was that we used to compute one by one. Again, we from this we used to compute this. So this way used to compute, but in Rabin-Karp algorithm we actually don't calculate again and again. We just subtract the first what is gone, and what is coming we just add it, and in this way we keep matching with this. So we actually save a lot of portion, and this optimizes our code, and that is so the space and time complexity that we came to understand, that the time complexity is big of m plus n in Rabin-Karp algorithm. So these algorithms are quite complex. So I'm finishing this lecture, again meeting on the next video of KMP algorithm in better mood. So thanks, that was.